Hi, I'm Ethan Allen, your host on Likeable Science here on ThinkTech Hawaii. And as I've said before, Likeable Science is all about the idea that science is a vital and interesting part of everyone's life, not just the scientists. We should all embrace science and enjoy it. Here to help me explore that today is Bill Myers. Welcome, Bill.
Glad to be here.
Good to have you, good to have you. Bill is a retired nuclear physicist. He got a bachelor's degree originally in physics from Pennsylvania State University, worked in the Navy for several years, was a business manager for General Atomic in San Diego, went back to school and got his doctorate in physics at Berkeley, did some postdoctoral fellowships and came back to Berkeley where he was on the staff for 20 years. Since he's retired, he has been tutoring, mentoring, volunteering with a wide variety of great organizations around here, the Rotary Club and Friends of the Library, the High School Science Fair, all these different groups, sailing clubs, and also helps out in robotics classes. And that was sort of what brought us together a little bit, was his interest in robotics. And indeed, he brought a sample here of a robot. But so maybe tell us a little bit about what got you into robotics. It seems to me like something of a jump from nuclear physics to get to robotics, but maybe not.
The robotics started out as a hobby. It's hard to do nuclear physics by yourself. So as a retired person, I was looking for something that I could embrace completely. And my ex-wife, one Christmas, bought me this LEGO robot. It's very reasonable, $300 or something like that, and I absolutely loved it. One of the things that's wonderful about it is that you could put it together with no tools. You don't need a screwdriver or, or a drill or anything. So that was an attraction. The other attraction is that it has a graphic computer language that you use to program it that's kind of fun. And so I decided that this was the kind of mental exercise I needed to keep myself from, mentally slowing down.
Very good, very good. It's good that you recognize that. It's important for all of us to keep our brains in shape, as it were, by doing good exercise. And yes, this idea of a visual programming language, as it were, a non-word-based way to control a device like that is a very powerful idea, I think. There's a popular computer program called Scratch, which uses blocks that do certain things, and you start putting these together they only fit together in certain ways, but allow users to make computer animations do all kinds of activities they want. And this is fairly similar, apparently.
It's similar to that. The LEGO robot comes with its own graphic language. There's another language that's used in many of the competitions. There's robot competitions going on every day. It's all over the place. It's an enormous enterprise. And very often the language used in those competitions is something called LabVIEW.
Right.
And LabVIEW is also used to program satellites, military fighter planes, autonomous underwater submarines, whatever. And I think it's wonderful that you can get your toe in the door with something so small as this.
Indeed. This whole robotics interest has been growing for quite a few years. Back in the 1990s, Dean Kamen started the U.S. FIRST competition, and teams of students and their engineer advisors would get a whole set of components and be told to build a robot that can stuff this basketball through a hoop and or stop other robots from doing this. And so they would then pit these robots against one another and have these competitions, and it's become quite a popular model for learning. It engages kids, it gets them out of classroom type learning, gets them into much more real world type learning, where they're actually having to form teams and work together as coherent groups, each person or group of people having their own job, and it's a valuable kind of learning.
I just read a book recently that where the author got really excited about this LEGO robot and the LabVIEW programming language. He remembered when he was younger that all the nerds would get together after school and they were doing exciting, interesting things with electricity and ham radio. Later on, high fidelity, building your own amplifier and speakers, how exciting that was.
Sure.
And he got it in a position where he was at a school and he tried to recreate that excitement for the students. And it didn't work at all.
Mm-hmm.
It fell totally flat. No matter what they did, nobody cared. But then one day, somebody brought in one of these little robots and it took off like a rocket.
Mm-hmm.
Times change.
Yeah.
This is the new ham radio.
Right, but the fundamental principles of this are actually fairly similar in a way. That is, it's got sets of components that in and of themselves do only very limited things, but as you start combining them and putting them into more complex systems, they properties begin to emerge that are quite interesting.
Yep.
And you take your diodes and transistors and all that only do limited stuff, you put them together, and then you have a device that allows you to communicate over vast distances. And it's quite the same kind of thing here. You've got a bunch of separate little bits and pieces that in and of themselves may not be very snazzy, but together they make this robot that can do all kinds of tricks.
Yeah, you mentioned transistors. You know, that was an intermediate stage. Some people are still interested in building things, but transistors and circuitry, a lot of young people these days are not interested. They've gone beyond that. They're accustomed to working with systems.
Mm-hmm.
And here we have it. The nuts and bolts underneath is often not that interesting.
Right, but arguably an understanding of that underneath stuff is actually fairly critical at some depth of knowledge to begin to really fully exploit the device and make it really do everything it's capable of doing.
Well, maybe we're thinking a little bit differently here. At some point, I had what I think is a kind of epiphany, you know. You don't have to learn math, science, physics, electricity in order to be able to do this. Mm-hmm. That's the Western model. Mm-hmm. I spent some time in the Marshall Islands, and I talked to kids there and some people that were just starting college, and the attitude was more that they would like to learn in a mode that's apprenticeship-like, mm-hmm. like someone skilled not to lecture to them, but to do things and bring them in.
Right.
So all of a sudden I realized that this robot can be assembled without tools. It can be programmed by people maybe even who don't know how to read and write. Mm-hmm. And the learning that you refer to comes after. Mm-hmm. At some point they realize to go beyond the simplest things, they need to know a little bit here or
right.
a little bit there. And then it fans out.
Right.
And that's kind of the opposite of the way I grew up and the way a lot of us are used to thinking about.
Right. There is a reciprocal relationship between interest and learning, and we often think of it as just a one arrow that You get interested in something and learn about it, but as you learn about it, you get more interested in it too, and the two drive each other.
Exactly.
And so, but yes, it's, in a sense, I get what you mean, though. It's sort of like driving a car. You don't have to understand how the internal combustion engine works in order to be a perfectly fine driver and to drive your car. You can know nothing about the internal combustion engine and still do that. But, and so yes, here you don't have to know circuitry particularly. But
yeah, a wonderful example that was cited in this book I referred to is trigonometry.
right.
Do you have any recollection about learning trigonometry? How incredibly difficult it was,
Right.
and how absolutely pointless it seemed to be?
Totally, totally.
He cites an example of some kids who were doing a little robot project, and they needed a little bit of trigonometry.
Right.
And they went to the trigonometry teacher and petitioned for a couple days worth of trigonometry to get them over the bump. And
Yeah,
so that's
beautiful.
that's the kind of thing that excites me.
yeah, that's what you want. You want people seeking out the learning they want to do,
Absolutely.
because then they'll have that, if they've got that motivation, they will do the learning, it will stick with them, they'll understand, they'll fit it in with their larger schema of knowledge, they'll work well with it, and they'll keep learning more then. If you just tell them, read chapter 7 in the math book and take the quiz, that means nothing.
Yeah, I'm really excited about the idea of putting together something like a little workshops that would last 3 or 4 weeks, and maybe 10 or 12 kids, and half a dozen robots, and just run a little apprenticeship program. And afterwards, if possible, leave the robot behind. And the kids will either carry on or they won't. But at least you've opened the door.
Right, right. That could certainly be fun to do, and we could set something like that up to do with local communities here, or
yeah.
as you say, on some of the islands. But so this is then it's really a combination, you're saying, of these two things. One, this fairly tool-free robot.
That's right.
And this visual programming language that again, that's a sort of, in a sense, a word-free tool for controlling it.
Almost.
Yeah.
I have the fantasy of trying to teach robotic programming to kids with whom I don't have a common language. It's a challenge, and it would be really fun to see if it can be done.
That would be. I recall getting furniture from IKEA where the directions had no words at all in them, and it was just a matter of, you looked at these diagrams, you understood how it had to, had to go together. And there was a little more complex to do it with something like this. But no, that would be a very interesting challenge to undertake, to see if you could really teach kids to do that.
Yeah.
And I think it can be done. There's who's the guy over in India who has installed computer terminals in just obscure spots in these remote villages in India, and just sort of puts them on, and then walks away. And the kids start using these and learning. They'll learn English in order to access these computers and start learning and teaching themselves all kinds of stuff.
I've heard about that. You may recall it started off with a hole in the wall.
Yes, exactly. That was right.
They cut a hole in the wall of his factory or something, and sat a computer there without any instructions.
Right. And pretty soon, it comes back weeks later, and the kids are doing sophisticated biochemistry or whatever. It's truly amazing what kids will learn if they are properly motivated.
Yeah.
Well, this is great. We're gonna explore this a little further. When we come back, we're gonna maybe turn this thing on and get it to perform some of its tricks, just to sort of see that. But
we can do some real simple things,
Right.
but it's fun.
Sure. But that'll be after our break. You're here on Likeable Science. I'm your host, Ethan Allen. With me today is Bill Myers, nuclear physicist. We'll be right back.
Hi, my name is Seymour Kazimirski. I have a show called Seymour's World on ThinkTech Hawaii. Our show is about opening minds and facilitating conversations. To tell you the truth, I have no idea what we're going to be talking about. I have no idea who our guests are going to be, but I guarantee you we're going to have lots and lots of fun. Aloha from Seymour's World.
Hi, my name is Andrew Howard. I'm an astronomer at the Institute for Astronomy at the University of Hawaii up in Manoa. I'd like to tell you about the annual open house that we're having. This year it is on April 6th, 11 to 4 p.m. It's an all ages event, kids, grown-ups, even people in between, everyone is welcome. We have a lot of really fun activities. You get to meet astronomers, look at yourself in an infrared camera, play with Legos, make robots, look at videos. You can even make some of the kids like to make comets out of gravel and snow. Even adults like to do that too. You'll be able to look at the sun with a solar camera safely. It's really a great activity. We do this every year in April, and I hope to see you this year. Thanks.
And you're back here on Likeable Science, here on ThinkTech Hawaii. I'm your host, Ethan Allen. With me in the ThinkTech studios today is Bill Myers, a nuclear physicist. We're talking about robotics, and we actually have a robot here. And I thought I'd see if Bill can get this to demonstrate just a few very, very basic activities, and maybe we can look at some of the controlling language for it, and you'll really see what we mean by this visual programming language. But first, can you put it through its paces?
Okay, I'm going to turn it on. I think I'm going to need my glasses. I want to look for the software files.
So this is great in the sense it doesn't require an external computer to drive it. It's got-
Previously, I put a computer program on here that consists of 3 little blocks, very simple. And now I'm going to turn the computer on and ask it to start up the motors, run forward for 1 second, and then stop. That's really simple.
Right.
But big, complicated programs
Just
are built by linking together these
simple little steps, right.
things. So here we go, 1 second.
Okay, there we go.
That was it. I don't know if everyone is impressed or not. But here, let me show you the computer program that brought about that activity.
Right. So there's three.
Can you see that?
There's 3 blocks on this. There's a block that says basically power on, and it starts to go. That runs essentially into a block that gives it a timing control basically, and says keep going for 1 second. And once it's finished with that step, it moves on to the 3rd step, which just says break. And so it's just 3 very simple little commands.
You put those blocks together, connect them by a line, and then store it on the computer, and you can do it again and again whenever you want to.
Right.
Let's do something a little more complicated.
Sure.
Here's
Right. We can.
a program.
Right.
It turns on.
So this turns on 2 different motors.
Yeah.
Going, interesting, I see a minus sign here. It's turning one motor one way and one motor another way.
Yeah, one wheel goes forward, the other one goes back.
And then again, it runs, in this case, not for a length of
Waits
time.
for
but
720 degrees. That means it allows the wheel to turn 2 rotations.
Right.
And then it releases it, and the thing that happens next is put on the brakes and stop.
Right. So can we demonstrate this?
I've turned up the power a little bit, so
Okay.
the activity here is going to be a little more vigorous.
Okay. So it's interesting to think about when we see this doing these very simple routines. And please go ahead.
Okay, here we go.
So there we go. We saw it. We can do it again.
The wheels turn twice.
Right. But equally, you could run that with a 5-second timer rather than rotations of the wheels.
I could ask the wheels to go slower or faster.
You could free it up from the wheel turns and turn it into a time thing. Keep doing that for 5 seconds.
Different kinds of turns. You could put the brakes on one wheel.
Right.
And just let the other one go forward, and then it would spin in a different way.
Just as in your previous example, you could have it run forward until it ran into something, for instance, and
yeah,
you have a sensor on this too, which will stop it when it runs into things.
For what we've just done, all that was necessary is this little control unit here and the 2 motors driving the wheels. But
this is bells and whistles.
I've added a lot of bells and whistles here just to show people what the possibilities are. This is a light sensor that looks down. It knows whether it crosses a line or not.
So you can set up a set of commands to tell it basically to stay on a line, more or less.
On a line, or
say on one side of a line.
Labyrinth of some kind. It should find its way through. This will let it know.
Yes.
If there are walls that it might run into, this little push button is that kind of a sensor. Up here we have a sound sensor that you can talk to, so you can or whistle.
So you can give it commands if or when you hear a clap, that'll stop it or go. Yeah.
Underneath, here's a claw that can reach out and grab things.
And again, that would just be a matter of simply programming that in to open, run forward, grasp, and close.
Underneath is a distance sensor that can tell how far away things are. So you can tell it, don't get any closer to the wall than 10 inches, and it'll stop.
Right.
So in the little package that I would use to try to teach people the robot and the computer language, at this point, when you know how to go and you know how to turn, a challenge like this one is an appropriate next step.
Okay. So you make your robot start somewhere and ask it to go from point A to point B, and you need to program it to do that.
Yeah, so you can say, go 10 inches up, turn to the left. Go 20 inches, turn to the right.
Go 10 inches.
Go 10 inches, turn to the right. Go 10 more inches, and you're at the end. Let me show you what the program looks like to do that.
Okay, so that's, yes, you begin to see how this gets more complicated.
So now it's starting to get a little more complicated.
But still, you can see it's these same simple little blocks that you can look at any set here and realize it's a very simple 1 or 2 commands, and they just are strung together.
Yeah. Well,
it's
why don't you point at them, Ethan? It starts off by go.
Right, it starts off with the go.
And then it's turn left.
Okay.
This whole package here is what's necessary to turn left.
Okay.
And then it's go again.
Right, okay.
And then there's another package which is turn right.
Okay.
And then it's go again. Another package, turn right, and then go again.
Some more, right.
It's all the simplest, easiest, most transparent things.
It's beautifully logical, and it teaches kids to think logically what's needed to do this sort of seemingly complex task.
That's a really big part of it.
Right.
Let me show you what the next step is in learning this programming. Those packages of complicated instructions that say go or turn right, you can draw a line around it on the screen and say, let's give that group of things a special name.
Like turn right.
And then the program that was that complicated looks like this. This is exactly the same program.
It's a summary of it, basically, yes.
But the little boxes contain the complexity
Right.
that was on the other
Right.
one.
And then similarly, you could probably take and put this whole thing as a box, as it were.
You got it,
And
and
combine
then
it with
gets
more
more
box.
and more
Right.
complicated.
And this is why now they have, I was watching recently this little video on a little quadricopter, so a small flying device, right?
Oh, yes.
That you put on essentially an electroencephalogram hat, a hat that's measuring your electrical outputs from your brain, and fairly quickly, by just imagining doing certain movements, opening or closing your right hand, opening and closing your left hand, you can make this thing hover, turn right, turn left, go forward, rise, lower, and people, a lot of people within a relatively few minutes can learn to fly this quadricopter by just thinking sort of logical thoughts in a sequence.
Well, if there's anything that's crystal clear, is to move forward in the society that we live in today. You have to be able to talk about robots. You have to think a little bit about how robots do things and what they're capable of. And a major part of what people are going to be doing in the future is interacting with or producing new robots.
Right, and particularly here on the islands, I see a tremendous opportunity in that robots inherently are very good for undersea exploration because we aren't very good at it. We are limited by our need to breathe air and things like that. They don't have these limitations, and so being able to develop robots with the proper sensors to do particular forms of explorations, either going out and searching for certain substrates or certain kinds of plant life, or looking at temperature profiles of the water, or salinity, or contaminants. Again, you can begin to see the options, and it all builds off of very simple stuff like this.
There are wonderful things being done. I was, one of my other hobbies is sailing, and I was at the Kaneohe Yacht Club a few months ago, and lo and behold, sailing into the harbor was an autonomous robot that had just sailed to Hawaii from the mainland, all by itself.
Wow.
I've done that trip myself, and when I did it, we went a little faster. I think the robot took a month or something.
So no worry, didn't have to eat.
But it was amazing, and what an interesting project.
Right.
There's another robot sailing project, not sailing exactly, but a robot ship that doesn't use the wind as this robot did. Instead, it makes itself heavier, and as it sinks, it's designed like an airplane, and it goes forward.
Oh yes, okay.
And then it goes back to the surface, and it also goes forward.
Right.
And it gets up, checks to see where it is, decides what's to do next, and then it continues on. The propulsion is
incredibly simple.
somehow there is no propulsion. You
Right,
know?
right.
It just goes up and down, but because it's a glider,
Right.
it keeps going where it wants to.
Right, and these are being used for all kinds of data gathering now in the oceans. And there's
what a fun robot
right.
to design.
And now they're getting the robotic cars are being tested out and driving all around California. And now they've got one going across the country. And
These things make me a little anxious.
I actually can't wait. I'm very nearsighted, and so I can't wait for the days of the robotic car to be here.
Oh.
So a car that I won't have to worry about driving. You know, that'll be fun. Well, this is excellent, and we're going to come back and talk some more about the future of robotics, where we see it all headed. But we're going to take a small break before then. So you're here on Likeable Science with me, Ethan Allen, your host on Likeable Science, and with me today is Bill Myers, nuclear physicist, and we're talking about STEM learning from radio to robots. We'll be right back.
Inspired by an ancient culture, classical Chinese dance, vigorous physicality, timeless stories, 5,000 years of Chinese music and dance. Shen Yun presents authentic Chinese culture. Coming to Blaisdell Concert Hall, May 8th and 9th. Tickets at shenyun.com or call 808-792-3919.
Hi, I'm Jay Fidel. That's Ted Ralston. You know, Ted is the host of Where the Road Leads. It shows every Friday from 4 to 5 p.m. It's about technology. It's about how people collaborating and solve problems with modern technology. It's where the road leads. We all know that. We should all be listening. Join us there, 4 to 5 p.m. every Friday. Now, what about that do you agree with?
All of it.
I knew he'd say that. Aloha. Say aloha.
Aloha.
Good.
Sit on the time.
And we're back here on Likeable Science. I'm your host, Ethan Allen. We're broadcasting here from the ThinkTech studios in downtown Pioneer Plaza in Honolulu. With me today is Bill Myers, a retired nuclear physicist. We've been talking about robotics, and we have our Bill's robot here that demonstrated a few of its very simple tricks. And we were talking about the programming and how it's sort of you get sets of commands, string these together, make a sort of block of them, and begin to string those blocks together, encircle your blocks, make super blocks, and begin to put those together, and thus begin to develop very sophisticated behaviors by feeding in inputs from its various sensors and feeding outputs to its several different motors. So this seems to me it really opens up a whole realm of things. We touched on this just before the break a little bit about some of the potentials for robotic cars, robotically controlled flying vehicles, undersea. But where do you really see this going? What do you see as the next big step here for robots?
Well, my interest is using the very simplest little robot like this one, and a graphic language that is easy to grasp as a way of bringing into what people call the STEM
Science,
fields,
technology, engineering, and mathematics.
This is not cutting edge technology, and it doesn't have anything to do with that. What my thought is there are technically inclined young people who, for cultural or economic reasons, don't find an opening into the STEM fields. They just come up against a wall.
Sure.
But maybe this is a way to break through.
Sure.
And so that's what is on my mind at the moment. I'm looking for a small group of young people, technically inclined, but frustrated by their environmental situation and unable to proceed.
So then my next question is, though, can you, once you've gotten, say, a group of kids learning about this robot, I mean, it's cute, it does a lot of fun things, but it seems to me one of the key components that drives a lot of people is sort of being of value to their community, doing something useful. And so that's sort of the next thing is, how do you make useful robots, right? How do you make robots that actually carry out tasks that you would like to have done?
I understand that thrust that you're describing, and it's not exactly the one that I'm on at the moment.
Sure.
You can do things with these robots. For example, you could build an XY plotter. You know, you have two motors. You could build a little Lego frame and and give it a program. And when you would type in a number 1, it would go over and up and lower a pen and draw something. So you could build a plotter. Might be very helpful in a laboratory for plotting scientific results. Might be useful in a kid's high school chemistry class. So there are, kids come up with things
Sure.
that they could do. What I'm hoping for, maybe I'm kind of short-sighted here, but the thrust that excites me is that after doing a workshop of this kind, the kids that are involved will not be so shy
Right.
in the face of technology.
Exactly.
So the next time there's a machine,
Right.
instead of standing quietly off,
Right.
embarrassed or unable to interact, some of them will step forward.
Right. They'll have this
And
self-efficacy.
that'll be because they have under their belt technology. So that's one, that
Right.
get over the shyness.
Right.
Number 2 is there's a vocabulary.
Right.
You learn words, motors,
Controllers.
detectors, and various ways of describing the robot. All of those words will allow them to interact with people that they couldn't have interacted with before.
Right.
And this is kind of shallow maybe, but the certificate of accomplishment that I plan to give to these kids at the end of the workshop is going to look really good on their resume when they make an application for, let's say, an off-island advanced school program.
Sure. Sure.
So that's what I want to do. I want to give these kids a lift. But when it comes to robotics, let me remind you that your dishwasher
Sure.
at home is a robot.
Right. Exactly.
And it's a rather capable one. It
Right.
does a lot of things.
Exactly.
One of these kids might decide that if the dishwasher at home needs to be fixed,
Right.
it might have been unthinkable previously,
Right.
but now it's just another robot. It's
Yeah, he'll-
not a big deal.
He or she will understand that machine runs on the same sets of logic blocks, basically, that control, that get this robot from point
Yep.
A to point B. Right.
I looked into taking an advanced course in this subject, and the exam at the end of the course was to design a car wash.
Okay.
When you think about it, you pull the car in and something acknowledges the presence of the car.
Right.
And then it hooks on and it moves it to a certain place and stops and turns the water on, turns it off, turns the soap on, turns it off. There's 1,000
Right.
things that need to be coordinated.
Right.
And once you start becoming aware of these things, in a restaurant, there are probably activities that could be correlated.
Exactly. I mean, getting a meal from ingredients to the table is very much the same kind of, even broken down into sets of very simple activities which have to be put together in the right way, in the right sequences. And if a plate gets dropped, I mean, there has to be those loops built in about you know how to go back and either start over or to take necessary correction, just as if this gets off track. You want to build correction factors on in again, more sophisticated programming.
So you're getting a little bit beyond me
Sure.
at the moment.
I'm just thinking.
My idea is to give the kids push into society, into the world we live in. And that's going to be enough. when I think about where to go with this, the next step is not necessarily building things with robotics, but the next step is to go to these same places with another workshop. And the purpose of this one is to train teachers to do it themselves.
Okay, very good, very good.
And that's as far ahead as I've been able to look at the moment.
No, and I didn't express myself clearly, but I was just saying that the way of thinking that's necessary to build these programs can be applied in many other jobs
Boy,
too.
that's
That
absolutely true.
That's what I was saying. In a restaurant, I mean, there is basically, it is just the same kind of breakdown of tasks as this thing has a sets of simple little tasks to do to get it from point A to point B. And in a restaurant, we have the same kinds of things. In a office environment, if you're delivering the mail, you have the same kinds of things. If you are running a car wash. You know?
Yeah, that's absolutely
I mean,
true. And it's a way of thinking that is not necessarily available.
Our schools don't often train you to do that very well. And the schools in the islands, I think, even less so. The teaching workforces there are not terribly well prepared in many cases. And
yeah, we're so used to being sent off with a book to sit and read something and then come back and regurgitate it onto a test form.
Right.
This is a whole different world.
Of course, the kids today just go on the internet and look it up and
Yeah,
download it.
Exactly.
So it's a different form of learning. But again, there's a lot of commonality here. But I think you're right. I mean, the ability, as you said, to take a set of simple components and quickly and simply put them together into a very sophisticated machine without having to know how to solder or build electrical circuits or whatever makes a great vehicle. And then when you apply this visual programming language, which teaches kids to logically break things down into component steps and put those steps together into logical sequences.
The instructions that come with the LEGO robot are amazingly thorough. One page says, pick up this piece and do that. And you have to go to the next page to do the next thing. So it's well within the ability of almost anyone. And that's really special in this day and age when things are so technical.
Right. You do need, for certain kinds, aspects of learning, you need that kind of very much step-by-step. Indeed, that's, in essence, the robot needs that all the time, right? It really needs that step-by-step. It cannot think in any real sense and play on it. It needs to have those steps very discreetly spelled out, just as the putting it together requires for the learner, you know.
Can I make a few remarks to your listeners?
Sure.
If these ideas interest you, I recommend that you go on the internet to YouTube, for example, and just search on LEGO robot. It's breathtaking how much fun and how much of interest these things can do. A half a dozen people have designed little boxes with this computer that will take, for example, a Rubik's Cube. I don't know about you, but I never learned how to do one of those. He's put a Rubik's Cube in it.
And it'll solve it for you, yeah.
And the robot solves it.
Right, yeah. There are huge communities of LEGO Robotics Mindstorms people. There's Mindstorm competitions and communities and...
Yeah, that's the other thing. There are hundreds of websites. There are forums. There are discussion groups.
Yes,
there are conferences. There are
it's
these
amazing.
competitions that grade school and high school kids get involved in.
Super stuff.
It's a huge community.
It is.
Of interest.
It's great, and I wish we had more time to talk about it, but we've run out of time. You've been with us here on Likeable Science. I'm your host, Ethan Allen. With me today has been Bill Myers, nuclear physicist and all-around robot guy.
The robot's name is George.
And George. We got George here with us today. So We hope you've enjoyed this. It's been a fun and enlightening exploration, and I thank you very much for being here.
I really
And I hope
appreciate
folks
it.
will join us again next week. Thank you, and aloha, Bill.